All right, in section 3.3 we talk about taking integration, but we're a little more careful in how we do it. We're trying to find the area between two curves, and so we have to be careful which function we list first and which one second, and that way we can find the actual area between two curves. Before we were doing area above the x-axis, something like this or this, but now we're doing the area between two curves. And so basically you're taking this larger area and subtracting the smaller area from it, and you get the area between the curves. And so you end up just taking the integral of two different functions. And so the area between two curves, as long as one function is continually larger than or equal to the other function, you just take the larger function minus the smaller function and you integrate the two. So you got two curves here. One's technically a line and one's a parabola, and you take the top curve minus the bottom curve, and your integral goes from 0 to 3 in this case. So you just do your integration like you would normally, but with just two functions instead of one. Nothing new there. This one, we're doing it again, but they don't give you the limits of integration, so you have to find out where these two functions are equal. That's what they're doing here. And when they set them equal to each other and solve, they get these two values for x, and so now you know it goes from -1 to +3. That's what you use for your limits of integration. And then you integrate the top function minus the smaller function, lower function, so the line subtracting the parabola there. Alright, now sometimes you have to be careful in how you do things, because if you look at from -1 to 0, the cubic is above the line, but then from 0 to 2 the line is above the cubic. So you have to break it up into two parts. You have to do the integration from -1 to 0 and properly put the cubic first and the line second, and then from 0 to 2 you're going to pick the line first and the cubic second. So you can't just be you have to be careful in how you properly divide up the curve properly, so that whatever function you're integrating, the first of the two functions is the higher or the upper function, and the second one is the lower one. Alright, so it asks you true or false. Over the interval AB, the area between the continuous functions f and g is just the integration of f minus g of dx. That's not true. That's false. It's only true if we know that f is greater than g or equal to g. B, if f is greater than or equal to g and the area between the curves is given by this, then x equals a and x equals b represents the left and right boundaries respectively of the region, and that's true. C, to find points of intersection of f and g, we have to solve f equals g. That's also true. We have to find the limits of integration. Alright, number 2, consider the function f and g here. Find the points of intersection. And so when you set them equal to each other, you find -6 and 2. Then you plug them into either function to get the y-coordinate. Okay, and then determine which one is greater, and you find that g is greater than f. So when you set up your integral, you list g first and f second, and then you integrate, and you get your answer. There's something called the average value of a function. What we've been doing is we've been taking the area under the curve, this shaded area here. But if you took the average of what the heights are, this is the highest, this is the lowest, and so the average is right about here. If you drew a line across there and looked at that region, you'd be looking at roughly the same answer as what was the area of the curve. So they ask you to find the average value of a function. And so if you know that the area is simply the area under the curve, integral of f of x dx, the area of this is b minus a times the height, the average height of f of x. And so if you just take, if you want to find the average value, you just take both sides and divide by b minus a, and your b minus a cancels here, and you get a over b minus a equals your average height or your average value of the function. And so if you know a equals the integral, you just divide both sides by b minus a. So that's how you get this. If you got a equals the integral, you divide both sides by b minus a, and you get a over b minus a equals 1 over b minus a times the integral. So this is what we'll be using when we're finding the average value of a continuous function. So that's exactly what they ask us to do here. So you use this formula, and we've got from 10 to 20, so your b is 20, your a is 10. Plug in all the values and integrate like you should, and you get this number here. And now B says, what's the average cost per unit if 40 lamps are produced? Well, you've got the cost function, and we know the average cost function is the cost function divided by x. So you got to take each one of these terms and divide by x, and you get this here. Okay, and then you just plug in 40 into the function to get your answer, and that's the average cost per unit if 40 units are produced. Alright, this one's same idea here, and they ask you for two separate functions for f and for g. They're over the interval minus 2 to 2, so you use b minus a from minus 2 to 2, so 2 minus the minus 2, and here's your integration, and you take the integral like you normally would. And you do the same thing here for g. That's your b minus a from a to b, and you integrate like you should, and you plug everything in. Alright, so the similar questions that are found on WebAssign, the very first one asks you to take this integral. They ask you to write down what the integral is, and we know it's from 0 to 2, and we know it's the function 4, y equals 4 over x squared, so 4 minus x squared. So when you integrate, you get this, and you plug in the values, and you get your answer. And this one is from 1 to 8. Integrate from 1 to 8, and the higher function is the cubic, and the lower function is 2 minus x. So the top function minus the bottom function, and you integrate it. And plug in your values, and you get your answer. Number 7. They don't give you the limits of integration, so you have to set these two equal to each other and solve so that you know what the limits are. And if you plug those values into either function, you'll get the y-coordinate. We don't necessarily need that. What we do need is the x-coordinates. And so you take the higher function, the line, subtract the quadratic, and you integrate that and plug in your values. 11. They don't give you the limits of integration, so you got to set these two equal to each other and solve, and you get three values. You get minus 2, 2, and 0. And when you plug those into any one of those functions, you'll get these same y-coordinates. Now, if you notice here, this is the cubic is above the line, and then for this part of the graph, the line is above the cubic. So from minus 2 to 0, you put the cubic first. Then from 0 to 2, you put the line first. And you got to do it in two separate integrals. And when you do, you get your answer, and your final answer is 8. 13, it said find the area of the region, and if you graph it, it looks like this. You've got a negative x squared here, and then you've got the x squared plus 2 there, and they want the area between 0 and 2, and it's just shaded area here. So it's just a matter of integrating and plugging in the values. Then for 16, they give you this guy, and this guy. So they give you these two functions, and then they give you the vertical line x equals 2. And so you've got this region here, so you're talking about going from x equals 1 to x equals 2. That's what your limits of integration are. And you're talking about this higher function minus the lower function. So you put the higher function first, the lower function second, and you integrate, and you get your answer. 21 is the same way as what we were talking about earlier. We have to be real careful about which function you write first. If you set these two functions equal to each other and solve, you get 0, 2, and minus 1. And these are the respective points that those give you. So from minus 1 to 0, we're going to put the cubic higher than the quadratic, so the cubic comes first. And then from 0 to 2, we're going to put the quadratic first and the cubic second. And then you integrate each one, and you get your answer. Here we talk about the average value. So again, it's 1 over b minus a of the integration from a to b of f of x. So you just integrate f, and you do 1 over 3 minus 0 in this case. And when you integrate that, you get this, and plug in your values, and you get 6. And this one, again, your values are minus 2 to 0, so 1 over 0 minus a negative 2. And your integration is from minus 2 to 0, and you integrate this function here. And you get this, and you plug in your values, and you get 0. 39, it says find the daily sales during the first 20 days of the campaign. So it's the same thing we just did in the last two questions. It's just from 0 to 20, and you're integrating. And you have to be a little more careful, because when you integrate this guy, your u is negative x squared, so your du is, or u prime, is negative 2x, and you don't have the negative 2 there. So you got to put a negative 2 into that function for it to work. And when you put a negative 2, you got to divide out by that negative 2 as well. So then this becomes, this part is just negative 50, and this is e to the u prime dx. And so if it's e to the u prime dx, you just get e to the u. And we know what our u is, it's negative x squared. And when you integrate dx, you just get x. And then you plug everything in, and you hit it with a 1 over 20 as well, and you get 102.5. B says the same thing, but they, instead of from 0 to 20, they want you to go from 20 to 30. And so when you integrate, you get the same answer. I didn't show all the work from here to here because we did it on the previous problem, so I know that the integral is going to look like this. The only difference is the number out in front and the limits of integration are different. But when you plug those in, you get your answer that's 100. 43, they talk about time release capsule with the number of milligrams in the bloodstream given by a formula where x is the number of hours since the drug is put into the bloodstream. And so you're finding the average. So 1 over, if we're going from 0 to 4, it's 4 minus 0 in the denominator here, and 0 to 4. And you got this complicated function here, but it's pretty straightforward. It's just you add 1 to the exponent and divide by that new number. Add 1 to the exponent and divide by that new number. Add 1 to the exponent and divide by that new number. And the numbers are kind of complicated. They're not easy to work with, but if you use your calculator, just type in 18 divided 7 plus 1, hit enter, and then hit math 1, enter, and it'll give you 25 over 7. And then 11 divided 7 plus 1, hit enter, and then hit math 1, enter, and it gives you 18 over 7, and same thing here. I multiplied each one by the whole numbers out front. Then we plugged in a 4, then we plugged in a 0. The 0 part, that whole thing just goes away. It's this part that's really going to give you your answer. So, and when you calculate that very carefully on your calculator, you get something that's approximately 147 milligrams.